What I would like to do now is, again, working on this example from the book Learn Your Haskell. I have this new type created called Barry, and we learned how am I going to deduce the kind signature for Barry, and I'm going to now show you how I'm going to tie up some of the material that we've been learning here by making Barry an instance of the type class functor. Okay, so for this video, we're just going to revisit the, the type class definition for the functor class. So the class functor in Haskell, is defined as follows. So I have a class functor and I have a type variable f where where I have a type signature for my method fmap, where fmap has a type signature. It has a type signature where it takes in a function that goes from a to b as the first argument, and it takes in as an input a second argument, which is f of a, giving you back as an output something of type f fb. Okay, now remember, this piece over here, is my type signature. This is my type. This is my type signature, and what that means is that the kind for f of a is must be a concrete type. The kind for f of b in this case must be a concrete type, and the kind, well, this is a function over here. A function in Haskell also has a concrete type here. Okay, so this is going to be a concrete. I mean, if you look at, if you start from this function here, I see that it has two type variables a and b. A in this case has a kind of star, and b in this case has a kind of star here. Okay, and so in this case, I already know that a has a kind of star, b has a kind of star, meaning that the kind for f is that it takes in some concrete type, giving it back as an output a concrete type. This is the kind for f. Okay, so the kind for this f here is that it goes from a star to a star. Okay, so what it means is, if at any point you've created your own class, and you would like that class of yours to be an instance of the functor type class in Haskell, what's important here is that you can only make those classes an instance of the functor's type class that has a kind of star going to a star. This must be obeyed. This is absolutely a strict constraint. Okay, in the previous video, I had created a type Barry, and we also deduced from the last video that Barry has a kind. It has a kind that has the following kind signature. If this has the following kind signature, can I make Barry an instance of my functor's type class? Well, I cannot use Barry as it is, because the kind signature of Barry and the kind signature that is expected in my functor's type class are two very, very different. If I look at the kind signature over here, let's call this 1, and if I look at the kind signature for this entire thing, and let's call this 2, I can see that both of them are completely different. But what I can do is I can partially apply on the type constructor Barry enough arguments so that the kind signature of Barry with the partially applied arguments will match the kind signature for this 1 year. And what I mean is that if I take this Barry, okay, and let's say if I were to apply in this case, let's just say Barry, and let me just make sure I have my notations correctly, so so that if you're following with this textbook, you won't. I don't deviate too much from what is mentioned in Learn Your Haskell. So Barry followed by a type variable a, where a has a kind. It has a kind of this entire piece. Let me just make sure my colors are consistent. So this piece over here in yellow or this orange or darker yellow has this kind of going from star to a star that is associated with A. And then finally, I'm going to have Barry A followed by another type variable B, where B is something that has a type signature of, or the kind signature of this star here, okay, this star here, meaning that Barry AB together has a kind signature of star to a star, which completely matches what is expected for F here. Okay, so let's do that. So what I'm going to do now is I'm just going to create an instance, and I need some space here. So let me just erase some space here. Let's just get some space here, and let's just make Barry AB an instance of my functors type class. So I'm going to say instance functor, and this f over here, which needs a kind of star to a star, I'm going to pass in Barry AB, because Barry AB is something that has the same kind signature of this f here, where let's just provide the complete implementation for my fmap method. So now I need the implementation to my fmap method. What does fmap method take in as my arguments? Well, it takes in a function. It takes in this function here. Let's just call it function f. Okay, I just pass in a function f as my first argument, and I'm going to use pattern matching. To pass in this second value. Okay, now what is the second value here? If I look at this f of a here, meaning this f a, I know f now is this entire piece Barry AB. Okay, so let's just replace f with Barry AB. Okay, followed by this argument, in this case a. Now instead of calling that a there, let's just make it c. Let's just make it c. Okay, just so that we don't confuse with this a. And what I'm going to do now is I'm just first going to make this entirely completely done here. So wherever we see an A in these type signatures, let's just make them as C, and wherever we see B in these type signatures, let's just make them as D. Meaning, I'm just going to rewrite this. As first thing C to D followed by F of C followed by F D. Okay, I'm just replacing my A's with my C's, and I'm replacing B's with my D's here. And again, I'm just doing this so that I don't confuse with this A that I'm just introducing here, and this B that I'm just going to introduce here as part of my type constructor Barry. Okay, so what is the signature for, or if I were to just rewrite the type signature again using the type constructor Barry, what I'm going to have now is C to D is going to remain as it is, but in place of F, I'm going to rewrite as Barry of AB, okay, followed by that C there, followed by this F again gets replaced with Barry of AB, okay, followed by that D there. Okay, now again, because we're in the type signature here, we know that this must have a concrete type. This entire thing must have a concrete type, and this entire piece over here must have a concrete type here. Okay, so let's just use pattern matching here. So if I use pattern matching here, I'm going to say the implementation to the fmap method is going to be, the first argument is going to be f as it is. The second argument needs to be some value that happens to be of type Barry ABC. Okay, how do I create a value? Okay, how do I use pattern matching here? Well, I can use pattern matching here because I know that the value of Barry ABC, if I'm saying Barry ABC here, and again, just so that we are a little bit consistent with our variables, instead of saying TKP that I originally had, let's just rewrite this as data vary, or you know what, let's just rewrite this on top of it. So let's do it this way. Instead of writing as tkp now, tkp, let's just make this as abc. Okay, so just it becomes a little bit easier. So now wherever I see t, I'm going to replace that with an a. Wherever I see a k, I'm going to replace that with a b, and wherever I see a p, I'm going to replace that with a c. Okay, so some value that happens to have a type of Barry ABC is this piece right there. This is my value constructor. This is the value. If I use pattern matching here, I can say Barry followed by I'm just using pattern matching there. My first field Yaba, and let's say Yaba has some value, X, and this value X has a type. It has a type of C, followed by the second component Daba, which has some value Y. It has some value Y that happens to be of type AB. Okay, this is a type AB of my value Y. What is this entire thing going to be equal to? Well, this entire thing needs to be equal to some value of type Barry of A, B, and D. Okay, how do I create a value of type Barry of A, B, and D? Okay, so now, again, if I want to say A, B, and D, this is A, B, and D. Wherever I see C, let's just put a D there. Okay, so what I know is that this value that I need to create there of some type Barry of ABD, at least the second component Daba is going to be as it is. Daba isn't going to change. And because Daba isn't going to change, I'm going to have Barry followed by Yaba. Okay, let's just complete Yaba a little bit later, and let's have Daba. Let's just have Daba, which is going to have the same value. It's just going to have the same value Y, and the reason I'm going to have the same value Y because I know that the type of Y is AB. The type of Y is AB. That's why I'm pattern matching, right? If type of Y is AB, I also know that the value that I need over here, which is Barry ABD, is also going to have the second component as it is. This isn't going to change here. But now, if I look at the type of X here, the type of X is actually C, right? The type of the value X happens to be type C. But if I take this function, which is my function f, and I pass in X, what I get back is some value of type D, and that is exactly what I need here. I need some value of type D to completely have a value of type Barry ABD. Okay, again, remember, this is the function fmap that I'm trying to implement. Okay, and to implement this function fmap, I must not deviate from this type signature when I happen to make Barry AB an instance of my type class functor. Okay, and this is my first argument f. What is f here? F is some function that has a signature that goes from C, some type C, giving me back some value of type D. Then using pattern matching, I have some value over here that happens to be of type of Barry A, B, C. And finally, I'm going to give back as a value some value that happens to be of type Barry ABD. That Barry ABD is this entire piece right here. Okay, Barry ABD is going to have a value which is Barry type constructor followed by Yaba, and Yaba is going to have a value of type D followed by the second component Daba, which is going to have a type of AB. Okay, and I already have that value that has a type of AB, which is this Y. This Y over here has a type of AB. That's why I'm reusing that Y again at this point. And finally, I need some value of type D in this box here. I need some value of type D. How do I get that value of type D? I'm going to make use of my function f that goes from type C to type D, and I'm going to complete this box. I'm going to complete this box by passing in the function f, and on the function f, I'm going to pass in my argument x. Okay, and I pass in x here. F of x is going to give you some value. It's going to be some value of type D.